Hey there, STEM Chemistry. Now we're going to learn how to name acids, write the formulas for acids, and we're going to learn what a hydrate is. Woo! I know you're excited. Okay. All right, so naming acids. There are a bunch of different ways. I'm a liar. There's a couple different ways that you're going to name an acid, and it depends on what kind of acid it is. So you can have a binary acid or you can have an oxyacid. A binary acid, binary means two, right? So there's two different components to it. And so how do you tell the difference? Well, first off, you know it's an acid because it has an H at the beginning of it, right? HCl, H2SO4, HNO3. These are all acids because they have a hydrogen at the beginning. Okay, so if it's a hydrogen attached to a nonmetal, we call it a binary acid. And if it's a hydrogen attached to a polyatomic ion, we call it an oxyacid. Okay. Now, in order for it to be an oxyacid, there is one more thing that has to be in there. If it is an oxyacid, it has to have oxygen in it. Oh, okay. All right, so binary acid, and the way you name it depends on the state, the physical state that it's in. Okay, so if it is not aqueous, if it says it's HCl, gas, okay, so if it has this physical state thing behind it, and it says that it's a gas and it's not aqueous, then you're going to name it by saying hydrogen and whatever the nonmetal is. If it is aqueous, aqueous is AQ, and we'll get into the different states, solid, liquid, gas, aqueous, all that very soon. But just so that you know, if it is aqueous, you're going to name it hydro, whatever the nonmetal is, and add IC as your suffix. So in this case, it's HClAQ, aqueous, it would be hydrochloric acid. All right, so examples of these. It says to name the following compounds. So here we have HBr, but there's an S after it. So it's not aqueous, and we would name this hydrogen bromide. And we would name that because it is a solid. It's not an acid. It has to be aqueous. It has to be a water-based solvent in order for it to be an acid. So here we have HI, and some of you will be like, oh, look, it's Hawaii. Okay, and it's aqueous, so it is an acid, right? So we're going to name it hydroiodic acid. Okay, so when we name it, when we take this nonmetal part right here, we're usually taking like the root of whatever the nonmetal name is. Okay, so on this one, H2S, it's aqueous, so we're going to name it hydro. And then it's sulfur, so we're going to put sulfuric. Oh, my pen went a little crazy there. Sorry, sulfuric acid. Okay, but Ms. Ruark, you just said you're going to take the root of it. Okay, well, typically you're going to take the root of the name. Now, there is an exception to the rule, which happens to be sulfur. Okay, and then the same thing when you do phosphorus. Right? When you do phosphorus, most people would think that they would take phosphor and then take off the US. But guess what? That's not the case. When you do phosphorus, you take off the orus, so you have phos, and you would add your ending to it. Yeah, I know. Okay, we'll practice. All right, H2S, and it's a gas this time, so we're going to name it hydrogen and then sulfide. Okay, so make sure you pay attention to what physical state it's in. Okay, naming acids. If it's an oxyacid, it does not depend on what physical state it's in, only binary. Okay, so there are some steps you have to follow when you're naming an oxyacid. So you're going to name the polyatomic ion. Yes, you need to know your polyatomic ions. And the end of the polyatomic ion, if it ends in ITE, you're going to replace ITE with OUS. You have your ites and your eights in your polyatomic ions. Your ites get replaced with OUS, and your eights get replaced with IC. Now, there's a way I can remember this, and that is by saying I ate something icky. Okay, so I know there's another saying for the ITE and the OUS, but I can't remember what it is. But I ate something icky helps you remember that your ATEs go with your ICs. And then if it's not in that, then it has to be the other one, right? Okay, and then you change your root if necessary for pronunciation's sake, such as sulfur and phosphorus, right? Because those two are weird. And then you add acid to the name. So here we have H2SO3. Is it a polyatomic ion? Yeah. How do we know? Because it's got sulfite right there. Okay, sulfite. And sulfite is SO3 with a -2 charge. All right, so sulfite. We take off the ITE. We add OUS to it, so it would be sulfus, but guess what? Sulfus doesn't sound right, does it? No, sulfur's one of those weird ones. So we're going to make it, we got to make it pronunciation correct here. Okay, so sulfurous acid. And that's all you have to do. It's okay. Yeah, it's not bad. All right, so write the name for the following acids. So HNO2. This is NO2 is nitrite. All right, so we take off the ITE and we add OUS, so it becomes nitrous acid. Yeah. All right, and ClO4. ClO4 is perchlorate. And I ate something icky, so we take that off and add IC. It becomes perchloric acid. All right, go ahead and pause, try C and D, and then come back and check your work. Okay, PO4 is phosphate. I ate something icky. We take that off. Phosphic. That just doesn't sound right, does it? It doesn't sound right. I just told you that's what it was on the last screen, and I was wrong. Oh my gosh, Miss Ruark, you're horrible. I know, I make mistakes, but at least I account for them. Okay, so it's actually going to be phosphoric acid. I did it backwards. Most people think you would stop at the phos. That's what it was. But you don't. You keep the phosphor and you take off the last part. So it's phosphoric acid. See, I mix myself up all the time. Oh my goodness. Okay. And then CO3 is carbonate. We take off the ATE and we add IC and it becomes carbonic acid. Awesome. Okay. All right, writing formulas from names. So how do we do that? Well, first we have to identify the ion that's involved. Okay, if the acid starts with the word hydro, it is not a polyatomic ion. Okay, not a polyatomic ion. If it says hydro at the beginning, then you know it's going to be hydrogen and then whatever else is attached to it. Yeah. If there's no hydro, and the acid ends in OUS, then the polyatomic ion ends in ITE. See how we're going backwards? Oh, yeah. If there's no hydro in the name and the acid ends in IC, then the polyatomic ion must end in ATE. All right. Woohoo. Let's see. If there is a prefix on the acid name, then there's a prefix on the polyatomic ion, right? Hypochlorous comes from hypochlorite, so you have to keep that prefix in there. And then you're going to use the charge of the anion to decide how many hydrogens you need to use in the formula to balance it out and make it complete. All right, so here's some examples for you. Let's go through the first four together, and then you guys can try these four, and when you come to class, remind me that I need to go through those. All right, so carbonic acid. Carbonic, there's no hydro at the beginning, so it must be a polyatomic ion. It has IC at the end. We change IC to ATE, so it's going to be carbonate, and carbonate is CO3 with a -2 charge. All right, since it's a -2 charge, that's how many hydrogens we're going to have, so it should be H2CO3. Okay, let's try another one. Okay, nitrous, OUS gets changed to ITE. Nitrite is NO2 with a -1 charge. There's one charge here, which means we need one hydrogen, HNO2. Woohoo! All right, sulfuric. Sulfuric, IC gets changed to ATE. Remember, that's the weird one, so you have to make it sulfate. Sulfate is SO4 with a -2 charge. 2 here, so we're going to have H2SO4. All right, See, all of those they did not have hydro at the beginning, so we just wrote it out. All right, on this one, look, there's a hydro here, which means there's no polyatomic ion. So hydrogen and then chloric. Chlor sounds like chlorine. Oh, looky there. All right, so chlorine has a -1 charge, which means it's going to be HCl. Okay, I want you to try E, F, G, and H, and then bring those into class, and we will go through them tomorrow. Yay! All right, what's a hydrate? So a hydrate is a compound with a specific number of water molecules attached to it or associated with each formula unit. Okay, now remember, formula unit is the crystal structure, and that's where your ratio of metals to nonmetals come from. It's in the crystal structure, and you can have numerous you could have a huge crystal structure or a small one, and that's why it's a formula unit. And then a molecule is going to be for a covalent compound. So make sure that you understand the difference between a molecule and a formula unit. All right, so here the hydrate has water molecules that have been embedded into the crystal structure. So an example would be calcium acetate heptahydrate. So the compound is calcium acetate, and then it's saying that there are 7 heptahydrates, 7 water molecules that have been embedded into the crystal structure. Whoa. All right, so you can also have something that we call anhydrous. And if it's anhydrous, it's in its pure form, and that means there's no water added. So the example would be calcium acetate, or we would say anhydrous calcium acetate. Okay? So anytime that you hear anhydrous, that means that there is no water embedded into the structure. Okay. So hydrate versus anhydrous forms. So you have these two pictures here. Anhydrous cobalt 2 chloride. Just cobalt 2 chloride has a very characteristic blue color. If you've ever heard of the color cobalt blue, that's where it comes from. All right, well, cobalt 2 chloride hexahydrate, which means that it has those water molecules stuck in its structure. It has that nice red color to it, so they are different. All right, how do we write formulas for names for hydrates? So we identify the ions involved. We crisscross the charges to write the formula. It's just like an ionic compound. We use parentheses or force fields for polyatomic ions, and then we identify the number of waters in the hydrate with a I don't know what I was going to put here. We'll come back to it. Okay. All right, so here are your prefixes. And multiplication sign with a dot? I don't know. I can't remember what I put here. I just get ahead of myself sometimes. Okay, so how do we do this? It'll make sense. Magnesium sulfate. So magnesium is Mg with a +2 charge. Sulfate is a polyatomic ion, SO4 with a -2 charge. Remember, we have to do parentheses around the SO4 because it's a polyatomic ion. We cross our charges down. The 2 comes here, the 2 comes here, so we get Mg2, SO4, 2. Okay, the question is, what happens to the 2's? They simplify. And when they simplify, do I write my 1's? No. And if I don't have to write my 1, that becomes a 1, that becomes a 1. Do I need to keep the parentheses? No. So we should have MgSO4. All right, so magnesium sulfate, but it's heptahydrate. So we put dot, which means times. Hepta is 7. With a number, maybe? Huh? I don't know. Oh, go back, go back, go back! Sorry. Okay, and then hydrate for... What happened? It does not like me no more. It took... Oh, technical difficulties all the time. Okay. All right, 7H... There we go. 7H2O. So that's how you would write magnesium sulfate heptahydrate. All right, so pause it and try this one real quick and then come back. All right, you have cobalt with a +2 charge because it's cobalt 2, and then chloride is Cl with a -1 charge, and we cross those down and we get COCl2, hexahydrate, so times 6 waters. And there you go. Okay, now it can go on to the pretty picture. Okay, and I'll see you in class.